bond type, and physical properties.
That's right. How do we know? By looking at the letters, is it ionic or covalent or metallic?
Right.
And then do they have different properties?
Of course they have different properties.
Of course they
Ionic compounds behave this way. Covalent compounds behave that way. Metallic compounds behave a different way. And it's all related to how the atoms are bonded together.
There you go. So physical properties of ionic compounds, are they soluble specifically in water?
Some are. Some are not. But we'll do that with a different chapter. They are generally soluble in water and polar solvents.
Yes, generally. They form conductive solutions only. So when I put them into solution, that if it dissolves, it will conduct electricity.
Yes.
That's a ding, 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 right? Winner, winner, chicken dinner. If it conducts electricity, it is ionic, and you need to know that in solution.
Correct.
Okay.
These will typically have very high melting and boiling points because ionic bonds are extremely strong. The electrostatic force of attraction between the positive and negatively charged ions in an ionic compound is extremely strong. So they don't want to come apart, and they have to come apart in order to melt or
add energy. Add energy to break bonds, and in this case, you have to add a lot of it.
Bingo.
And hence, because of this, it has this crystalline structure that gets very three-dimensional and very complex, very hard to break. Hard to break, it fractures. If you hit it with a hammer, it's literally going to smash. It's not going to mush.
All of the rocks and minerals that you have ever come into contact with in life are made of strictly ionic type compounds. All right.
Some sort.
A rock is a mixture of many different minerals, and a mineral itself is a pure ionic compound. So they're very hard, have cleavage, fracture, all that kind of stuff.
Got it. Now we're going to move on to covalent. I know it looks the same. Keyword here in parentheses, molecular. That's a code word. If you hear molecular in a Regents question, that's saying covalent. Ding, ding. Hint. Are you listening?
Some are soluble, some are not, but generally speaking, all are slightly soluble in water and
slightly
non-polar solvents.
Non-conductive in a solution or as a solid.
Correct.
Neither ionics or covalents can conduct as a solid. One can in a solution, one cannot.
Melting boiling points are low because covalent compounds, in order to determine if they have a higher boiling point, they have to have an intermolecular force of attraction. So it doesn't actually take much energy to get two different molecules to separate from each other.
Because they're not really holding on.
They're not really holding on to each other. Unlike ionic compounds where they're like stuck.
Now, and if you think about this, you put sugar on the stove, you can turn that into a black, smelly mess real quick when you turn it on.
But you put salt on the stove.
You're just going to hurt yourself because it needs to get up into the 750, 800 centigrade. Higher. So that's into the thousands in the Fahrenheits. And your stove can't do that at home. My stove can't do that at home. And it's just going to get really hot, and it might start popping around like a Mexican jumping bean, hit you in the face, and then you're not very happy. So don't do that.
While every molecule does technically have a crystal structure, covalent compounds, they're very difficult to get them to make crystals. So generally speaking, in their normal, see them everyday state, they have very soft, non-crystalline structures. They don't fracture. They're like powders, most of them, or gases.
Think of powdered sugar or like brown sugars. You know how it kind of like rolls over itself weird?
It's not
soft.
Not good at making crystals, these things are not good at making crystals.
Okay, metals. They are going to be insoluble in water.
Yeah.
Like full metal on solid. It's not going to dissolve.
Put an aluminum can in water, nothing happens.
This is the only thing that actually conducts as a solid.
For electricity.
Will conduct electricity. Okay. Of course, super high melting and boiling points, even higher than ionics.
Because if you really look at the bonding in metallics, they're strictly held together by this cloud of mobile electrons. There's really no reason for these atoms of metal to want to actually separate.
Ever.
So you got to pump a ton of energy in them to get them to move apart from each other.
Yes. Yep. And then their crystal structure has a lattice with, again, mobile sea of electrons. That's the code word for why the electrons are able to move and conduct electricity and heat so readily.
And even why the metal is malleable and has a high melting point and boiling point. It's that mobile sea of electrons that's kind of just keeping them all together. Why would they want to move?
Right.
Everybody's got happy octets. Why would we want to get separated?
So just a quick, these are called Venn diagrams, right?
Yeah.
Of the properties. So covalent covalent compounds are going to be two nonmetals. There's key. Have we mentioned that yet this
Two
unit?
nonmetal elements. No, not
We
really.
need to hammer that. So
It's a shortcut. I'd refer you to know the real truth of why.
Okay, just check.
So I'm
Just
cool
checking.
with it.
Two nonmetals, non-conductive, low boiling point, melting point, and A is soft. How about you do ions?
Ionics. Well, this is a metal type element plus a non-metal type element. So two opposite ends of the periodic table.
It's ironic that they're ionic.
Yes. They are conductive in solution, and when they have been turned into a molten salt, that they will conduct electricity, but that's not very common.
No.
They have very high melting points and boiling points.
It is very common that they go into solution.
Yes, they do
That part
dissolve
is-
in
yeah.
solution.
That part is very common.
They're hard crystals.
And then what they all have in common is they're
Stable octets,
Yep, they have full valence
covalent
shells.
shells,
And they're
bonded together.
compounds.
The compounds. Absolutely.
Yeah. So guess what?
That's all, folks.
Cheers.
Push the button and I turn it